In our last lesson, we were learning about the tangent ratio, and we learned that the tan of an angle, and we can use the symbol theta, theta is just the Greek letter to represent an unknown angle, the tan of angle theta is equal to the ratio of the side opposite the angle divided by the, or compared to the side that's adjacent to the angle, and that is never going to be your hypotenuse. Hypotenuse is a side all to its own self here. So with this, we were able to find angle C. So the tan of angle C ends up being the opposite, which is 1 over the adjacent. So opposite, this is opposite to angle C, and then the 3 centimeters is adjacent or next to angle C. So to get what angle C was equal to, we undid the tan by doing the inverse function tan, or using your shift button with tan, on the 1/3, and we found that that was equal to 18 degrees, or 18.4 if we go to 1 decimal place, and that's degrees. And make sure you put that degree symbol there, otherwise it's assumed to be radian measure, and we don't deal with that until you get into grade 12. All right, complete the table using angle C as our angle of reference. So similar to last time, we're going to figure out the length of the side that's opposite. So that's your vertical side. So 1 centimeter for this one. The side adjacent was 3 centimeters. And then we're going to use those and the fact that it's a right angle triangle to calculate the hypotenuse. So my hypotenuse squared would equal the sum of the squares of the lengths of the other two sides. So that's going to end up equaling, that's a 2 there by the way, 1 plus 9 is 10, so h would equal the square root of 10, and we only need the positive square root because it is a length. So the square root of 10, which approximately is equal to 3.1623. 3.1623. And then we'll do the ratios after, but calculate what each one of these lengths will be, and then you can check your answer with the video. Now I've chosen to leave my hypotenusi all as the roots, so I have exact answers to work with here. Now we're going to take the ratio of the opposite compared to the hypotenuse. So the length of our side opposite angle C was 1, and the length of the hypotenuse was the square root of 10. And this I am going to take to a decimal amount here, and that's approximately equal to 0.3162, I believe. 3162. And then the second one, if I do the ratio of the opposite, that's 1.5. Let me just change to the red, 1.5 divided by the square root of 22.5. And then when we do that actual division there, again, we get that consistent ratio of side lengths. And that should make sense because these are similar triangles, which we explained why in the last video. And then the last one here, or no, second last one here also ends up being 0.3162. And the last one as well, when we do 2.5 divided by the square root of 62.5, we end up with approximately the same amount, 0.3162. All right, and similarly, we're going to do the ratio of the adjacent side, which in this case was 3 compared to the hypotenuse, which is the square root of 10. This time, we get approximately 0.9487, if you round that carefully. And then if we have 4.5 divided by the square root of 22.5, again, that ratio ends up being the same amount. So similar triangles, that scale factor gets divided out when you put that fraction in lowest terms. And so that ratio ends up being the same regardless of how big or small the triangle is, as long as it is a similar triangle. So while the tangent ratio is the ratio of the opposite compared to the adjacent, we have these two new ratios, and the first one is called the sine ratio, the sine of your angle of reference. So your sine of angle C, or theta, This one is your opposite compared to your hypotenuse. Opposite divided by hypotenuse. And your cosine ratio, so cosine, which is also written as the cos, and sometimes we say cos of theta, is the ratio of the adjacent side compared to the hypotenuse. So tan, sine, and cos are what we call the three primary trig ratios. And if we were to actually apply these to our triangle that we have above, we'll see that our angle C is going to equal the same amount every single time. So if we actually calculate the sine of angle C with respect to angle C, that ratio, regardless of which one we choose to pick here, that ratio ends up being that 0.3162 approximately equal to. So we'll just use that, 3162 approximately. And then to get C, we're going to undo the sine just like we undid the tan by using that shift button or second function button, whatever it is that we access that sine to the negative 1 with. And then we put that in our calculator, and you will see that C is equal to approximately 18.4 degrees, which is exactly what the tan ratio told us it was going to equal. Similarly, we can do that with the cosine. So the cosine of angle C would equal this ratio, which is the 0.9487. 0.9487. Again, to get angle C by itself, we're going to undo the cosine by doing the inverse function on cosine on the 0.9487. And again, we see that C is approximately equal to 18.4 degrees. All right, so those are our three primary trig ratios. And the way you can remember it is with a little mnemonic. That's where we take or an acronym, where we take the first letters of things to help us remember. So that is where this thing called SOHCAHTOA comes in. So you may have heard of SOHCAHTOA before. The letters all represent something. So S stands for sine. Sine is the ratio of opposite compared to hypotenuse. Cosine is the ratio of adjacent compared to hypotenuse, and tangent is the ratio of opposite compared to adjacent. So that is a way to help you remember. If you have trouble remembering how to spell that, that can be a little bit tricky. Think of sine as sin. Oh, you have sinned. Cos kind of reminds me of the word cash. Ah, I have cash. Let's go spend it. And then tan is ooh, ah, look at the tan. And my dog wants out. Hold a moment. That's what happens when somebody's in the kitchen. She thinks she's going to get a little treat. All right, so SOHCAHTOA, you need to remember this for your next couple of years of math. All right, let's look at the little triangle I have given you here. Let's talk about angle C in this triangle. I know that the side that is the hypotenuse will be the 13 because it's across from the 90-degree angle. And it's really important that you can identify which sides are opposite, adjacent, and hypotenuse in your triangle. Otherwise, this whole SOHCAHTOA thing's not going to work. Across from angle C will be opposite. And then the last side, or the one right next to angle C, is your adjacent. So if I want to state the three trig ratios for angle C, the sine of angle C is opposite, which is 5, over hypotenuse, which is 13. And the cosine of angle C is the adjacent, which is 12, over the hypotenuse, which is 13. And the tangent of angle C is the opposite, which is 5, over the adjacent, which is 12. Now, we can do this all in terms of angle A. We can never do it in terms of angle B. Angle B is 90 degrees. It's always got hypotenuse opposite to it. You can never call a side a hypotenuse and an opposite or adjacent at the same time. It's hypotenuse. You can't use your 90 degree as your angle of reference. With respect to angle A, the sine of angle A would be opposite. So 12 in this case is the opposite this time, over the hypotenuse, over 13. The cosine of angle A would be adjacent So this time the 5 is the adjacent over the hypotenuse, and then the tangent of angle A is the opposite over the adjacent. So you can see some things kind of switch roles here. These are just flipped over, and then the sine kind of goes with the cosines. These kind of flip-flop between the two. So just keep that in mind. It's all going to depend on which angle you talk about as your angle of reference. So we're going to do some examples on the next video.